Hello my dear students, welcome back to NEET World. So in this session we are going to discuss 8 marks question from class 12th organic chemistry, right. So most of the students will really face difficulty to understand the questions of this organic chemistry from class 12th right now. So in this session I will be explaining you very clearly and the very easiest way possible, so that you will feel more confident and you can learn them easily, okay. So attend this session completely and make your preparation effectively, okay, right. So let's begin the discussion. Yeah, so now before that, this is our C60 material. Yeah, you can access this material for free of cost from our NEET World app. Just go to Play Store, download NEET World app, log in using your mobile number, then you mention your class and group in the chat box. Then our team will guide you how to access all your maths, physics, chemistry for MPC students and biology, physics, chemistry for BPC students, okay. That's why you just mention your class and also group, that's it, okay. And one more thing here, so if you see the syllabus, all the chapters are almost completed. Yeah, we have few questions to be discussed from this organic chemistry from 8 marks questions only, right. 4 marks are also completed, 2 marks are also completed, right. So now here let's begin the discussion. Yeah, so if you see, these are some important questions we can expect. See, again from organic, why most of the people will feel difficult, because there is no fixed questions here, because every time they may change the way of asking question, because there are some list of name reactions. That name reactions may come as an individual question as a 2 marks, or that name reactions can combinedly come for 4 marks question, or they combinedly come for 8 marks questions also. It means you need to study some important organic reactions. From that list only we can expect questions here, either for 8 marks or 2 marks or 4 marks right now. Yeah, so for 2 marks and 4 marks completed, now we will be discussing for 8 marks here. See, read the first question here. I am saying, with a suitable example, write equation for coal-base reaction, Reamer-Timmer reaction and Williamson ether synthesis, then next aldol condensation. Now how many name reactions are included? Just see here how many they have included in this. They have mentioned coal-base, Reamer-Timmer, next Williamson, next aldol. These are the 4 name reactions. Again, all these are very important and very easy. I will tell you simple tricky ways to understand them and remember them for the final exam, okay. Just follow this session. See, first one they are saying about coal-base reactions now. Yeah, so forgot about all these things. Whatever I am explaining here, just remember this. See, coal-base reaction means it's not coal-base electrolysis, it's coal-base reaction, okay. Now what happens in coal-base reaction is, you just take phenol. What you need to take? Phenol, okay. Phenol means like benzene ring with OH group, phenol, okay. And you know, you are much familiar with carbon dioxide right now. So phenol plus carbon dioxide, okay. This reaction takes place in basic medium, okay. See, all these compounds you are much familiar, like phenol means structure you know, and the next carbon dioxide you know, and the next one is NaOH. So these 3 combined to give you a product like this, phenol, like as it is I am writing, and here you are adding this CO2 now, CO2 and this OH, so it will be giving you COOH. Like this you are going to get the final product. So the product name here is ortho or salicylic acid. What is it? Salicylic acid, okay. So now salicylic acid. So what is this salicylic acid? I will tell you, just follow this. Salicylic acid. So I will tell you once again. See, phenol plus carbon dioxide in base, in presence of base you are going to get salicylic acid. So now read the statement once. Phenol react with sodium hydroxide. Yes, so phenol react with sodium hydroxide and forms a sodium phenoxide. See, phenol plus sodium hydroxide, this is an acid, here is a base, so it will form a sodium phenoxide ion now, okay. On heat, on heating with carbon dioxide, acidification gives you orthohydroxybenzoic acid. This product is called, IUPAC name is orthohydroxybenzoic acid. Now what is the common name of this product? Salicylic acid, that's it. These are the things to be remembered here, that's it, okay. Hope Hope the discussion is clear. Guys, if this is clear, please hit on the like button. So once again tell me, what do we mean by Kolbe's reaction here, Kolb's reaction here? It's very easy. Phenol with NaOH upon treating with carbon dioxide gives you salicylic acid. The UPAC name of salicylic acid is orthohydroxybenzoic acid. That's it. This is the first question. Done. Up to here it is done. Okay. So you should represent in this way reaction after writing this normal theoretical part. Okay. The next one is Riemann-Tiemann reaction. Okay. So what is this Riemann-Tiemann reaction? See, same. Here you have taken phenol now. So in the same reaction, in the Riemann-Tiemann reaction also, we are taking phenol only. So here also we are taking phenol. Just follow what I am explaining here. Yeah. So just take phenol. So this is phenol. Here you have treated with carbon dioxide. Na? So in Riemann-Tiemann reaction you should need to treat with chloroform. Phenol with chloroform. Chloroform formula CHCl3. Okay, and this reaction takes place in basic medium. Okay, it means again you need to take here NaOH. Okay, NaOH. That's it. Okay, the product formed here is orthohydroxybenzaldehyde. Okay, this is salicylaldehyde. In the first reaction we discussed as salicylic acid. Now here you should say salicylaldehyde, because here we have aldehydic functional group, here we have carboxylic acid functional group. So it is salicylic acid, here it is salicylaldehyde. Okay, so these ortho products are major in both of this reaction. Okay, so now what is the name of this product? I told you ortho, or simply write salicylaldehyde. Okay, salicylaldehyde. Okay, that's it. Or otherwise, what is the IUPAC name? Orthohydroxybenzaldehyde. Okay, so this one is called orthohydroxybenzoic acid, and this one is called orthohydroxybenzaldehyde. So these are the two reactions you have completed till now. Okay, one is Kolb's reaction, other one is Riemann-Tiemann reaction. Once read this, when phenol react with chloroform in presence of sodium hydroxide gives salicylaldehyde. This reaction is known as Riemann-Tiemann reaction. That's it. Okay, so first two reactions are completed. The next one here is Williamson's ether synthesis. What is this next reaction? Williamson ether synthesis. So what happens in Williamson ether synthesis? Just again listen to me, do not make any confusion. See, Williamson's, see, ether synthesis, it means we are going to produce ether as a product. What is our product? Ether. Sir, what do we mean by ethers first of all? See, you know water molecule now? Water molecule means you are writing hydrogens on both sides of this oxygen. Now in the place of hydrogen, if we are placing any alkyl groups like methyl, ethyl, propyl, like that, if you are placing any alkyl group, then you can say them as ethers, like ROR is called ether. Okay, now just compare with water molecule, both hydrogens are replaced by alkyl groups. This is what ether means. Okay, now how do we prepare this ether molecule, they are asking. For that we have Williamson ether synthesis. Okay, so during this Williamson ether synthesis, what happens, you know, for example, I am preparing ethyl, see, methyl, methoxyethane I am preparing. See, small group is called as oxy, methoxyethane, this is the ether I want to prepare, or methyl ether I want to prepare. So what I can make here? So I want something like this, alkyl halide we need to take. See, alkyl halide means CH3Cl I am taking, methyl chloride. See, out of these two alkyl group, one group you take it as alkyl halide, other group you take it as alkoxide ion. Okay, another one is ethoxide ion. Okay, sodium ethoxide ion. Now see what is happening here. See here what I am saying, methyl chloride is there, ethoxide ion is there. See, chlorine is more electronegative now, so the bonded electrons are taken by this chlorine only, like this. If it is taking a bonded electron, what is the charge created on this carbon? Positive charge. Okay, alkyl group is getting positive charge now, so this ethoxide ion negative charge here is there now, so that electrons are given to this methyl group. Now what is happening? Chlorine is going out as a leaving group. There is a new bond formation between this oxygen and this methyl group. It means ethyl, oxygen, methyl. So this is what the final product. Yeah, this is what we have prepared now. Ethyl, oxygen, methyl. Ethyl, oxygen, methyl. So we got our ether now, that's it. So this reaction is known as Williamson ether synthesis. Okay, so very simple. The mechanism followed here is SN2 mechanism. What is the mechanism followed here? SN2 mechanism. Now listen here what they are saying. Alkyl halide, yes, methyl chloride we have taken here. So listen here. See, methyl chloride, yeah, alkyl halide react with sodium alkoxide. See, alkyl halide reacted with sodium ethoxide or sodium alkoxide to form ethers. Okay, this reaction is known as Williamson ether synthesis. That's it. You just mention these reaction steps. That's it. That will be giving you 2 marks. I mean, see, there are four named reactions. Each named reaction consists of 2 marks or having 2 marks. Okay, each named reactions for 2 marks. Like that, 4 reactions, 4 to the 8, like that. Okay, so this is how you need to understand. Okay, Williamson ether synthesis is also done. Okay, the next one here I provided one example, ethyl chloride and sodium ethoxide ion I have provided. So this ethoxide ion will attack on this carbon. So chloride ion goes out, you will get ethyl, oxygen, ethyl. So diethyl ether we got, that's it. This is what happens in Williamson's ether synthesis. Okay, is this clear? Reaction number 3, is that clear or not? Yeah guys, if it is clear, please hit on the like button, and if you are new to this channel, click on the follow button so that every day you will get notifications from our side. Okay, and you can share with your friends who are preparing for IPE exams. Okay, right. And at the last I will be I am going to tell you about EAP set, NEET exams, JEE exams also. First of all, listen to this IPE class first of all. Okay, see, now the next reaction here we have is aldol condensation. What is the next reaction we have? Aldol condensation. Okay, so aldol condensation, what happens? I will tell you one simple way here also, as we have seen for the last 3 reactions. Just follow these steps. Aldol condensation means you need to take either aldehydes or ketones. What I am saying? Aldol means you need to take either aldehydes or ketones. These aldehydes, ketones are called carbonyl compounds. What we can call? Carbonyl compounds. So now aldehydes or ketones having alpha hydrogen atoms. Okay, with what? See, if this group is there means you should say it as a carbonyl compound. Okay, now either any of the side, at least any of the side, there should be alkyl, like alpha hydrogens. What do we mean by alpha hydrogens? See, if this is a carbonyl group, the adjacent carbon is called alpha carbon, like first carbon is called alpha carbon. Don't count this adjacent carbon. I am saying this carbon is there now, it is called as alpha carbon. Now on this alpha carbon, if any hydrogens are present, those are considered to be alpha hydrogens. Okay, now in aldol condensation, alpha hydrogen containing carbonyl groups, alpha hydrogen containing carbonyl groups are aldehydes, ketones. Okay, right. So this is a acetaldehyde, I can say it's an aldehyde having alpha hydrogens. I am not discussing about this hydrogen, I am only focusing on this methyl group, like this alpha hydrogens only. So if we have any, at least 2 alpha hydrogens are required. So alpha hydrogen containing carbonyl compounds with dilute base. With what? We need to treat this with dilute base. Why we need to treat this? Yeah, I will tell you, just follow me. See, dilute base is nothing but it's a base abstract the acidic proton. See, base always try to abstract acidic proton. If there is any acidic proton, that is taken by the base. If there is no proton, then it will act as a nucleophile. See, here this alpha hydrogens we are discussing now, these are acidic protons. What I am saying? These are acidic proton. So this base will abstract this proton. Okay, anyways they won't asking us for mechanism here. Anyways I will explain mechanism also. First of all, I will give you one tricky way to answer this question, then we will see look into the mechanism, because if you know direct reaction equation, then you can expect for 2 marks. But even in case by chance if they ask for mechanism also, you should not get confused there, no. So I am going to explain you the mechanism also. First follow this simple trick to get the answer. See, carbonyl compounds like this containing alpha hydrogens with dilute base, see, gives you alpha beta unsaturated compounds. I will tell you what is this alpha beta unsaturated compound. You just take 2 molecules of this compound. Yeah, this is one molecule, and take one more molecule also, same this one only I am writing like this, see, like this, here dilute base I am indicating. Okay, so do not worry about anything, just remove this one, that's it, that will be giving you final product. See, from this alpha carbon, hydrogens you remove, 2 hydrogens you remove from here and oxygen from the adjacent. Okay, out of these 3 hydrogens you remove 2 hydrogen, out of these 3 remove 2. Okay, it means 1 hydrogen will remains with the carbon. Now what is the product forming? H, C double bond O, CH double bond with this carbon, H, CH3. This is what the final product will get. So you can see with respect to the carbonyl group alpha, beta. So we got an alpha beta unsaturated carbonyl compound. This is what the final product in aldol condensation. So what happens here? Heating gives you this compound. Okay, this is what happens here. Okay, now I will tell you. See, what is the tricky way what I told you? Take the carbonyl compound, remove alpha hydrogens from one compound, oxygen from other compound as a water molecule. So what we removed? Hydrogen H2 and O. Water molecule is removed now, so that you get this final product, that's it. The final product is called alpha beta unsaturated carbonyl compound. Okay, right. Now what are the mechanism steps involved here? This is what the important thing. See, here you read as per this 2 marks, this is enough, but in case if they are asking for 5 marks or 8 marks only from this reaction, but they are asking us to write mechanism also. Yeah, we can expect directly it as a 4 marks. Okay, that time you should not face difficulty. Just follow me what they are saying. When aldehydes or ketones having alpha hydrogens, alpha hydrogen atom react with dilute alkali, with what? They react with dilute alkali and they form beta hydroxy aldehydes. What they will form? Beta hydroxy aldehydes or ketones that upon heating gives you alpha beta unsaturated carbonyl compounds. Okay, right. So the intermediate formed here is called aldol. So this aldol upon heating gives you alpha beta unsaturated product. Okay, this is a condensation product. Okay, now I will tell you whatever the theory that we have written there, you just follow this step. Okay, this is what one carbonyl group. I am treating this with a dilute base like NaOH. Okay, by default what you consider, there are 2 carbonyl compounds we have taken, 2 molecules we have taken, out of that 1 molecule is reacting with a dilute base. This is what you need to understand here. So it will take a proton, acidic proton from here and forms a conjugate base like this, CH2O minus OH and H plus removed as water will get this. Okay, this conjugate base, this carbon anion will attack on the another group, another carbonyl group. We have 2 carbonyl groups we have taken, 2 aldehydes we have taken, out of 1 it is forming a conjugate, out of the 2 1 is forming a conjugate base like this. It means that proton is removed, you are going to get a carbon anion. So this carbon anion, what it will do is it will attack on this oxygen, on this carbon of the carbonyl group, so that you are going to get C double bond O, CH2, okay, that is attached to this one, CH. Carbon can hold 4 bonds only, no? Already 4 is there. The 5th bond is coming, means this pi bond will shift on to the oxygen. Okay, like this. Next is CH3. So this is what we will get. So now it will get protonated first, this one. Yeah. After writing this, see, we got alpha beta. So beta hydroxy carbonyl compound is formed. This is called aldol product. This is what? Aldol. Okay, aldol product. Okay, this aldol product upon heating, what we are doing? We are heating it. So upon heating, what happens is this OH group and this hydrogen from this alpha carbon will be removed as water and gives you a double bond between this, a pi bond between them. So C double bond O, CH double bond CH, CH3. So what is this? Alpha beta. So alpha beta unsaturated carbonyl compound is formed as a product in this reaction. Okay. So what is the name of this reaction? I am saying aldol condensation reaction. Okay. Right. This is what the question you can expect in the exam. Most commonly asked question. Yeah. So we can say without a question from either aldol or Cannizzaro, there is no question paper. Yeah. This is how we can blindly stick to this aldol condensation question. Okay. Either aldol condensation, Cannizzaro condensation, Cannizzaro reaction, and the next one is Riemer-Tiemann reaction. These are three questions like most times repeated. Okay, right. The next one here. Yeah, aldol condensation is over. The next one here is Cannizzaro we need to discuss. Yeah, I will explain Cannizzaro also. Okay, let us check once every question. Yeah, all 4 questions are completed. Kolb's completed, Riemer-Tiemann completed, Williamson's completed, aldol condensation done. Okay, the next here we have the second question, that is explain the following with one example. HVZ reaction, Cannizzaro reaction, esterification reaction, and decarboxylation. So 4 reactions here also. Each reaction contains 2 marks. So total 8 marks. Okay, this is also a 8 marks question. Okay. Yeah. So just read it. I will explain everything. Yeah, so look at this. Explain the following with one example like HVZ reaction, Cannizzaro reaction, esterification, decarboxylation. See here HVZ reaction, Hell-Horal-Zelinsky reaction. So what this reaction says, just listen to me what I am explaining. HVZ reaction means one of the very easy reactions. See, you need to take carboxylic acid. What you need to take? Carboxylic acid. So I told you that to the carbonyl group, if adjacent carbon is there, that is called alpha carbon, and that hydrogens are called alpha hydrogens. Okay. So in HVZ reaction, at least one alpha hydrogen should be there. So now what I am saying, the monocarboxylic acids are treated with halogen in presence of red phosphorus. The alpha hydrogen atoms of that acid are replaced by halogen atom of that reaction. Okay, that will be giving you alpha halo carboxylic acid. See, it means from this alpha carbon, if you treat this with chlorine, let us say chlorine in presence of red phosphorus. Now what happens is the hydrogen atom, this alpha hydrogen atom is replaced by this chlorine. That's it. Substitution reaction takes place to give you RCH COOH. Okay, so here you can write one chlorine. That's it. This is your final product. So alpha halo carboxylic acid, alpha halo carboxylic acid. This is your final product, alpha halo carboxylic acid as your final product. Okay. So what is happening here? This is a small transformation that alpha hydrogens are replaced by chlorine. That's it. Okay. So the monocarboxylic acid, yeah, carboxylic acids, upon treating with chlorine in presence of red phosphorus, like chlorine or bromine you can treat in presence of red phosphorus, gives you alpha halogenated carboxylic acid, that is alpha chlorocarboxylic acid is formed here. That is what the HVZ reaction gives us. That's it. This is about HVZ reaction. Next one is Cannizzaro reaction we have. So Cannizzaro reaction is like we just now we discussed about aldol condensation now. Yeah, so from relate like something like that, say, but there we required alpha hydrogens. Here no alpha hydrogens are taken here. See, it means aldehydes are ketones, like carbonyl compounds having no alpha hydrogens. In aldol condensation, they definitely alpha hydrogens are required like this. but in Cannizzaro reaction there should not be any alpha hydrogens like this. See, these are not alpha hydrogens. What I told you, to the carbonyl group adjacent carbon is present, on that carbon if any hydrogens are present, those are considered to be alpha hydrogens. Here these are directly attached now, these are not alpha hydrogens. Okay, so Cannizzaro reaction in which it can be like aldehydes or some ketones also, but there should not be any alpha hydrogens. Okay, so carbonyl compounds without alpha hydrogens upon treating with concentrated base, concentrated NaOH like that. Okay, concentrated NaOH like that you can take. So gives you a final product something like this. See, in aldol condensation also carbonyl groups, how many we have taken? 2 compounds we have taken now. So in Cannizzaro reaction also you need to take 2. By default you consider them as 2 molecules or 2 moles. Okay, but here there should not be any alpha hydrogens. There we have used a dilute base, here you need to use concentrated NaOH. Okay, right. So now what happens here is, here this concentrated NaOH act as a nucleophile. There it is acting as a base, here it act as a nucleophile. Now what happens is, there is no acidic proton now, directly this OH minus ion will attack here. Okay, out of these 2 carbonyl groups if we take, let us take them separately, so this OH minus will attack on one molecule. Okay, it will form a tetrahedral intermediate like this. Okay, now if it comes down, one hydride ion comes out. Okay, so COHOH, this is a carboxylic acid. See what is coming out here, hydride ion is coming out now. That hydride ion will attack on one more formaldehyde molecule. So this one will come and attack here. So you are going to get H, this is a newly added hydrogen and it is becoming O minus. Okay, this O minus will abstract a proton from here and you are going to get final product as methanol, CH3OH. This is methanol, one alcohol, and this is a carboxylate salt. These are the 2 products. So this is oxidized product, this is the reduced product. Okay, oxidized product and reduced product. Now what happened again, once again tell me, carboxylic acids with concentrated NaOH or KOH. Okay, sorry, carbonyl compounds like aldehydes without having any alpha hydrogens, upon treating with concentrated NaOH gives you one carboxylic acid product, one alcoholic product, that is one oxidized product, one reduced product. That's what happens in all in this Cannizzaro reaction. See, once read it, aldehydes having no alpha hydrogens undergo self oxidation, yes, self oxidation and reduction, yes, also one reduced product. Okay, in the presence of concentrated alkali. Okay, to give you one molecule of alcohol, another molecule of acid salt. Okay, so these are the 2 things formed here, that's it. This is what happens in Cannizzaro reaction. Okay, the next one here is esterification. So what do we mean by esterification? Again I will tell you. See, esterification, it means formation of ester. It means some compounds we are converting them into ester form. Okay, that's it. Ester is a final product. That is what the esterification means. Okay, right. Let's discuss about this esterification. Just follow me what I am explaining. You take carboxylic acid, to this add alcohol. What we need to add? Alcohol. So carboxylic acids upon treating with alcohol in acidic medium, in what? In acidic medium. Okay, in acidic medium, gives you esters as a final product. OR dash. See, what I did is this OH group and this H plus. If I remove as water, what is the remaining part? RC double bond O, RC double bond O, R dash O, that's it. That is the ester final product. So once read this, carboxylic acids react with alcohol, in presence of concentrated acid to form ester and water, okay, that's it. Okay, you can see acetic acid with ethyl alcohol in presence of acid catalyst giving you ethyl acetate. Ethyl acetate is an example of ester plus water is produced, that's it. Okay, this is what esterification means. And the next one here is decarboxylation reaction we have. So what do we mean by decarboxylation? Yeah, decarboxylation, the name itself saying no, decarboxylation, it means a removal. D means a removal, carboxylation, decarboxylation, removal of this carboxylic acid group is called decarboxylation. Okay, so you can treat carboxylic acids with soda lime, like CaO plus NaOH. This mixture is called soda lime. So carboxylic acids upon treating with soda lime undergoes decarboxylation. Just you need to remove this CO2 part. What you need to remove? This CO2 part. Now what is the remaining part? R and H. Now you just connect them RH. This is your final product. Okay. So what is happening, you can see, when sodium salt of carboxylic acid, or just remember carboxylic acids upon treating with soda lime, that is mixture of CaO plus NaOH, gives you carbon dioxide, this CO2 gas, carbon dioxide plus alkane as a major product, like carbon dioxide and hydrocarbon is formed. See, if it is an alkane, like saturated alkyl group, you will get an alkane. If it is unsaturated, alkene. Okay, like that, depending on R group, we are going to get a hydrocarbon product as a final one. Okay, I hope the discussion is clear. So decarboxylation means what? Just removal of CO2 from the carboxylic acid. So if you remove the CO2, whatever the next remaining part is there, you add it and make the final product like RH. Okay, see here carboxylate salt is mentioned, this CO2 and this Na, this O. So remove it as Na2CO3. So after removing Na2CO3, what are the remaining part? One R group, one H, that is forming RH. For example, here if I take acetic acid, CH3COO minus, okay, acetate ion I am taking, sodium acetate I am taking. Now upon treating with NaOH plus CaO, that is soda lime. So what I told you, just remove this part, CO2 and this Na, this NaO. Okay, so now what is the remaining part here? CH3 here and hydrogen. Methane we have, methane as a final product. Okay, that is your final product. Methane is a final product in the reaction. Okay, like this you need to understand the reactions here. Right, the next one here is describe the following things. See, what is the next one here? Describe the following. First one is acylation. What is the first one? Acylation. So acylation means we are adding, see, just read this. When alcohols react with acid chlorides or acid anhydrides, OH group is replaced by acyl group, okay, to form ester. See, it is very simple. See, what I am taking is CH3, CO, Cl. Okay, so this is called acyl chloride. Either I can take acyl chlorides, or I can also take acid anhydrides, or also I can take acid anhydrides. Yeah, this is fine. So acyl chlorides or acid anhydrides. So these upon treating with alcohols, with what? RCH2OH, alcohols. Now what happens is this chlorine and this hydrogen removed as HCl, and you are going to get the remaining one. See, just remove this part. Remove this part. What is the remaining thing? CH3CO OCH2R. So this is what acylation means. This is what the acylated product. Okay. See, we have added this acyl group. So this group is called acyl group. So this acyl group is added to our alcohol now. So we are going to get esters. Okay. What is this? Esters. Okay. Ester is a final product. See, when alcohol react with acid chlorides or acid anhydrides means like this. CH3CO, in the place of chlorine we have oxygen, and remaining again same thing like this. Okay, so it means this group is removed out, whatever the remaining acyl group is there, that is added to the alcohol. So alcohols with acid chlorides or acid anhydrides upon treating with alcohols gives you esters as a final product. Okay, alkyl esters as a final product. Okay, this is a reaction as an example. Here also we have discussed. Okay, the next reaction is Gutterman-Koch reaction. See, Gutterman-Koch is nothing but, see, benzene you take, treat this with carbonyl group like CO, carbon monoxide you can say otherwise. Okay, and treat this with HCl, okay, in presence of anhydrous AlCl3, anhydrous AlCl3. So what is happening here? First, if you consider this as a, like, if this is a combination of molecule HCOCl, if you consider it like this, you are going to remove chlorine and adding on the benzene ring now here also. So on the benzene ring you are adding this carbonyl group and this hydrogen here. So we are going to get a benzaldehyde as a final product. What is the name of this reaction? Gutterman-Koch. Koch carbonyl. Just remember Koch and this carbonyl group or carbon monoxide group. Okay. So read here, when benzene reacts with CO and HCl in presence of anhydrous AlCl3, it forms benzaldehyde. This reaction is known as Gutterman-Koch reaction. This reaction is known as Gutterman-Koch reaction. That's it. Okay. That's it. Okay. This is about Gutterman-Koch reaction that we have discussed. What is the final product formed in Gutterman-Koch reaction? It's a benzaldehyde. Then next, acylation I already told you. So acylation means what I told you, like adding acyl group onto the other substrate here. So when active hydrogen atom of alcohol or phenol or amine is replaced by acetyl group using acetyl chloride or acetic anhydride, the reaction is known as acetylation. Okay. So you can see one more example here. Acetylation means here we have chlorine. So this one treated with phenol, let us say. So now what happens in the phenol? This chlorine and this group removed, okay, and you are going to get a product something like this. This is also example of acetylation. Okay, acetylation of phenol. Okay, see this is also an ester product only formed here. Okay, the next example here is cross aldol condensation. See, aldol means what I discussed, carbonyl compound with alpha hydrogen that should be taken, treated with base and gives you final product as alpha beta unsaturated compound right now. So here by default we consider two carbonyl groups, I mean two aldehydes or ketones like methyl group containing two acetaldehydes we have taken there. So instead of taking two same molecules, if I take one acetaldehyde and one more other molecule, for example one acetaldehyde and one more is HCH2CH. See, both are different molecule. This is one, this is two. Two different molecules if we take and if we are treating them with NaOH followed by heating condition, okay, we are going to get a final product. Okay, see in this final product formation depends on what are the starting materials. See, I have taken mixture of two starting materials now, you are going to get mixture of products. So what are the mixture of products here? Whenever you are taking two different aldehydes with alpha hydrogens, different aldehydes are there, different carbonyl compounds are there now, so you are going to get a cross aldol reaction. Okay, it means this acetyl group can combine with itself and you are going to get a butane 2-ol, that is COH CH2 CH double bond CH, okay, and CH3. Okay, what is this product formed? See, when acetaldehyde with react with itself, you are going to get this kind of product. Okay, like that, first one can combine with itself, and you are going to get a aldol product, self aldol product. The second molecule also having alpha hydrogen, so there is a chance for itself to undergo aldol product, aldol condensation. So it means two type of product, or alpha hydrogens from first carbon, first alpha, this one first carbonyl group, and oxygen from second one. That means you are going to get two type of product, or alpha hydrogen from second, oxygen from first. You are going to get one type of product. So there are mixture of products formed. Total 4 different products formed here. So this is the scenario when you take a cross aldol condensation reaction. Okay. So if I take this molecule, they just represented it as mixture of butane 2-ol like this, but-2-enol and pent-2-enol are the products they are saying. Okay, so but all the possible products if they ask, you need to write in this way. Okay, that's it. These are the important organic name reactions. Okay, so the next one here, yeah, first you cover these 8 name reactions that we have discussed. Okay, if you still have time, please watch that organic session that we did for 4 marks and also we did for 2 marks. Okay, so from this most of the named reactions are covered, that whatever the important reactions are there, that are covered for your IPE exam. Okay, and one more thing, if you are preparing for EAP set or NEET or JEE exams, you can also join with us in our live sessions that we are conducting every day in this channel itself. Okay, so right now I have covered, I am discussing structure of atom. In the last class, before that I have discussed equilibrium. Okay, PYQ questions of NEET and EAP set questions were clearly explained in the last sessions. Okay, you can join with me and you can make your preparation really effective, right? And you can also interact with us during the live discussion. You can mention your concerns or your doubts in the chat box. I will definitely address them. Okay, so to reach us directly, you can contact us using a mobile number which are provided in the description box or on the main page of this channel. Okay, so thanks for watching. Share with your friends who are preparing for all these 11th and 12th standard exams. Okay, thanks for watching.